We were talking about solving exponential and logarithmic equations. And one way that we can solve exponential equations is we can take the logarithm of each side. And what that helps us do down here at the bottom, we can see that if we have an exponent and we have the log of both sides, one of the exponent rules is we can take the exponent and move it to the front joined by multiplication, and that can help us simplify or solve an equation that way. And so what we want to do here, we look at this equation, we want to solve the equations. We have an exponent that's variable, and we need to get that variable out of the exponent. So what we can do is we can take the log of both sides. So if I take the log, right now it's base 10. So log base 10 2 to the y is equal to log base 10 of 5. Now I can pick whatever log that I'd like. And in this case, because on the left side over here, we're taking the log of 2 raised to the y, it helps me out to pick my base of the log as 2. Because then we have another property that the log base 2 of the same base is equal to 1 eventually, and that will really help us drop that out. So the next step is, because we took the log base 2 of both sides, we can take the exponent, the variable out of, or that we can get rid of this variable out of the exponent, move it out front. So y is equal to log base 2 of 2, which is equal to log base 2 of 5. Now, one thing that we can take a look at, log base 2 of 2, what does that mean? Well, if you write this in exponential form, what it says is 2 raised to the x power equals 2. So what does x have to be in order for this to be true? X has to be equal to 1. So this whole thing right here, log base 2 of 2, is equal to 1. So with that simplification there, we get y is equal to log base 2 of 5. Log base 2 of 5 is a constant. We can calculate that. We can use the math function, substitute that into our calculator, and we get, we're going to approximate it, y is about equal to 2.322. And we can see, I just want to remind us of how we can substitute that in. If we have the math function right here, so we can click the math function, and then we can scroll down until we get to log base. Right there, log base, we hit enter, and then we can put whatever value we want. In that case, we want the log base to be 2, and we're solving it for 5, taking the log of 5, and we get about 2.3219, so we're going to round that, approximate it. All right, next one we have, same situation here. We have a variable in the exponent, so we need to get that out, and we want to take the log of both sides. And in this case, the side that has the variable on it is 7, so we'll take the log base 7 9 raised to the 9x power, and log base 7 of 15. The reason that we took the log of both sides is because we wanted to get the variable out of the exponent. So 9x log base 7 of 7 is equal to log base 7 of 15. This is equal to 1. And so we get 9x is equal to log base 7 of 15. And then we can divide both sides by 9. And then we get x is equal to log base 7, 15 divided by 9, which in this case we can approximate that. And we get x is approximately equal to 0.155. We have another example. In this case, we have to remember GEMDAs. So I'll write that down up here. So in order to solve this equation, when we're solving, we're going to start at the S, or subtraction and addition, and we're going to work our way to groups. So we have to do addition and subtraction, then multiplication and division, and then we can come to the exponents after we do those first couple things. So the first thing is we see subtraction, so we have to undo that. So we add 7. So we get 4e to the negative 0.3x is equal to 20. And so we don't have any more addition and subtraction. So next when we come to is multiplication and division, we can divide both sides by 4. And what we're left with is e to the negative 0.3x is equal to 5. Okay. Now we have the variable in the exponent. We don't have any other operations there. So we have to get the variable out of the exponent, and we have the base e, and we can remember that natural log is base e. So we'll take the natural log of both sides. And what that does for us is it allows us to take our exponent, our variable out of the exponent. So negative 0.3x multiplied by the natural log of e, which is equal to the natural log of 5. Natural log of e is 1. And so we can rewrite that as negative 0.3x is equal to natural log of 5 divided by negative 0.3 and we get x is equal to, and the natural log of 5 divided by negative 0.3. So we get x is approximately equal to negative 5.365.